Science 4, Quarter 1, Week 3. Chemical properties of materials and their uses. Matatag curriculum. Bansang makabata, batang makabansa. With me, Teacher KMP. Good day, kids! Today, we will learn about chemical properties of materials and their uses. At the end of the lesson, you are expected to A. Identify flammable materials and explain their properties. B. Recognize the importance of fire safety precautions and responsible behavior around flammable materials. C. Define chemical reactions and their significance in material interactions. D. Analyze the factors that influence material reactivity and predict outcomes of common reactions. E. Differentiate between degradable and biodegradable materials. And F. Evaluate the environmental implications of using degradable and biodegradable materials versus non-degradable materials. Kids, observe the books in your school library. Or observe the goods or food products at your home. Now answer the following questions. Number 1. How are books arranged in the library? Number 2. How are the goods or food products arranged inside your food cabinet or refrigerator? Number 3. How does it help when things are grouped properly at home? Matter has different physical and chemical properties, and these properties determine how it is classified, changed, and used. In the next phase of the lesson, you will learn more about other properties of matter and how to classify these materials according to these properties. Arrange the scrambled word. It is a measure of how quickly a specific material is capable of catching fire and burning. What is your answer? Correct. The answer is flammability. These are waste products such as packaging materials that can be slowly broken down into simple parts by chemical reactions or physical force. What is your answer? Good job! It is degradable. Waste materials that can be broken down into simpler, non-toxic substances by microorganisms. What is your answer? Good job! It is biodegradable. First topic, flammability. Flammability, it is a measure of how quickly a specific material is capable of catching fire and burning. Work example. Number 1. A piece of wood from a tree. Wood is natural material commonly used in construction and furniture making. Wood is flammable and can easily catch fire when exposed to heat or flame. It burns relatively slowly, producing heat and light. Understanding the flammability of wood is crucial for fire safety in buildings and forests. Number 2. A plastic drinking straw used in various products including packaging, utensils, and toys. Some types of plastic are flammable and can burn when exposed to fire or high temperatures. The flammability of plastic varies depending on its composition and additives. Awareness of the flammability of plastic is essential for fire safety in buildings, transportation, and waste management. Number 3. A cotton ball. Cotton is a natural fiber obtained from the cotton plant and is used in textiles, clothing, and medical supplies. Cotton is highly flammable and burns easily when ignited. It burns quickly and can produce a hot flame. Understanding the flammability of cotton is important for safety in clothing manufacturing, bedding materials, and medical applications. Number 4. A metal paper clip. A metal paper clip. Metals are solid materials characterized by their shiny appearance, conductivity, and strength. They include iron, aluminum, copper, and gold. Most metals are non-flammable and do not catch fire under normal conditions. They have high melting points and are not easily oxidized. Recognizing the non-flammability of metals is important for fire-resistant building materials, electrical wiring, and industrial applications. Second topic, how materials react with other materials. Materials can react with each other when they come into contact. This reaction can cause changes in the materials involved. Work example. Number 1. Rusting of iron. Iron is a metal commonly used in construction and manufacturing. When iron comes into contact with oxygen and moisture in the air, it undergoes a chemical reaction known as oxidation. This results in the formation of iron oxide, also known as rust. Understanding the reaction between iron and oxygen is crucial for preventing corrosion in metal structures and equipment. Protective coating and proper maintenance can help mitigate rusting. Number 2. Foam production in a hydrogen peroxide and yeast experiment. Hydrogen peroxide is a chemical compound often used as a disinfectant, while yeast is a microorganism used in baking and brewing. When hydrogen peroxide is mixed with yeast, the enzyme catalase in yeast catalyzes hydrogen peroxide's decomposition into water and oxygen gas. This reaction produces foam as a result of the release of oxygen gas bubbles. Understanding the reaction between hydrogen peroxide and yeast demonstrates the role of enzymes in catalyzing chemical reactions and is commonly used in educational experiments. Number 3. Aluminum foil reacting with air. Aluminum is a lightweight metal commonly used in packaging, construction, and transportation. When aluminum comes into contact with oxygen in the air, it forms a thin layer of aluminum oxide on its surface. This layer acts as a protective barrier, preventing further oxidation. Understanding the reaction between aluminum and oxygen helps prevent corrosion and maintain the integrity of aluminum-based products such as aluminum foil and aluminum alloys used in aircraft construction. Number 4. Weathering of limestone by acid rain. Limestone is a sedimentary rock composed primarily of calcium carbonate. When limestone is exposed to acid rain, which contains sulfuric and nitric acids, it undergoes a chemical reaction called acid erosion. The acid reacts with the calcium carbonate in limestone, dissolving it and causing the rock to deteriorate over time. Understanding the reaction between acid rain and limestone highlights the environmental impact of air pollution on natural rock formation, historical monuments, and building materials. The reaction between acid rain and limestone highlights the environmental impact of air pollution on natural landscapes and architectural heritage. It contributes to the degradation of limestone buildings, statues, and monuments, such as limestone facades of historic buildings and sculptures in urban environments. Number 4. Tarnishing of silver jewelry. When silver comes into contact with sulfur compounds present in the air, water, or certain materials, it undergoes a chemical reaction called tarnishing. Understanding the reaction between silver and sulfur compounds helps explain the tarnishing processes and guides the proper care and maintenance of silver objects and jewelry. Third topic, degradable and biodegradable. Biodegradable. Waste materials that can be broken down into simpler, non-toxic substances by microorganisms. Take a look at this picture. Microorganisms are sometimes called microbes and are tiny living things that are found all around us. These microorganisms can sometimes be classified as fungi or bacteria. Here are some biodegradable materials. First, paper towel. Second, banana peel. And third, cotton fabric. Degradable. These are waste products such as packaging materials that can be slowly broken down into simple parts by chemical reactions or physical force. A chemical reaction may include combustion, rusting, and digestion. Here are some examples of degradable materials. First, plastic straw. Second, polystyrene foam or styrofoam. And third, nylon fishing line. Learners' takeaways. Outline in the concept map what you have learned in the lesson. Utilize the given concept map below. You should be able to emphasize the following. Flammability or burnability. Some materials can catch fire and burn when exposed to heat or flame. For example, wood, paper, and certain types of plastics can burn. This burning process is a chemical reaction where the material combines with oxygen in the air to produce heat and light. It's important to be cautious around flammable materials and to never play with fire. Reactivity with other materials. Materials can react with each other when they come into contact. This reaction can cause changes in the materials involved. For instance, when iron or metal reacts with oxygen and moisture in the air, it forms rust. Similarly, when vinegar or an acid is mixed with baking soda, a base, it produces bubbles of carbon dioxide gas. Understanding these reactions helps us predict how material will behave when combined. Degradability and biodegradability. Materials can break down or decompose over time due to various factors such as exposures to sunlight, air, water, or microorganisms like bacteria and fungi. Degradable materials eventually break down into smaller pieces, while living organisms can break down biodegradable materials into simpler substances. For example, food scraps, paper, and certain types of plastic are biodegradable, meaning they can be broken down naturally by bacteria and other organisms in the environment. Let's do the activity. Read each question carefully. Identify the letter of the correct answer. Number 1. Which of the following best describes flammability? A. The ability of a material to dissolve in water. B. The ease with which a material can catch fire and burn. C. The tendency of a material to react with oxygen in the air. And letter D. The ability of a material to conduct electricity. What is your answer? Very good. The answer is letter B. The ease with which a material can catch fire and burn. Number 2. What is an example of a flammable material? Is it A. Glass, B. Metal, C. Paper, or D. Rock? What is your answer? Good job! The answer is letter C. Paper. When iron reacts with oxygen and moisture in the air, what does it form? Is it A. Aluminum oxide, B. Rust, C. Carbon dioxide, or D. Hydrogen gas? What is your answer? Very good. The answer is letter B. Rust. Number 4. Which of the following materials is biodegradable? Is it A. Plastic drinking straw, B. Nylon fishing line, C. Banana peel, or D. Styrofoam packaging? What is your answer? Correct. The answer is letter C. Banana peel. Number 5. What happens to a banana peel when it is discarded in a natural environment? Is it A. It remains unchanged indefinitely, or B. It decomposes into simpler organic compounds, letter C. It reacts with other materials to form new substances, or letter D. It breaks down into smaller pieces over time. What is your answer? Good job! The correct answer is letter B. It decomposes into simpler organic compounds. What have we learned today? Today, we learn about flammability. It is a measure of how quickly a specific material is capable of catching fire and burning. How materials react with other materials. Materials can react with each other when they come into contact. This reaction can cause changes in the materials involved. Biodegradable. Waste materials that can be broken down into simpler, non-toxic substances by microorganisms. Degradable. These are waste products such as packaging materials that can be slowly broken down into simple parts by chemical reactions or physical force. Kids, thank you for listening. I hope you have learned something. Do not forget to click the like, share, and subscribe.